Hello everyone, here it's Yuanhui, and here I'm gonna go over for question 5, the homework 5, question 1. And the question says, for x and y are independent with density function of x equal to mu x minus 1 minus mu x minus 2, and that function of y is equal to mu y minus mu y minus 1, and z equal to x plus y. So it's asking us to find the density function of density function of z. So there are two ways we can use. First one is convolution, and second one is geometric. So let's say the convolution at first. So you might predict the graph for fancy function of z is gonna be like here, 1, 2, 3, and height in 1, and the shape is like a triangle. So to get to this part, let me go step by step. First, so for either two calculation, I will use that's function for x versus y at least here, and I will shift 1 for that's function of y's to get mu x minus 1 minus mu x minus 2. And for here is the convolution function, and in the calculation, the alpha is between infinity and negative infinity. So here is the density function of x is alpha, and density function of y is z minus alpha. And to calculate this out, the next step it's like I tear it apart. So you can see in here mu alpha minus mu alpha minus 1, and times mu z minus alpha minus mu z minus alpha minus 1. And by step I just tear them up and separate in two parts, like here and here, and finally we can separate it like between z and 0 minus alpha times mu alpha times mu z minus alpha times mu z minus the alpha between z minus 1 and 0, get in this function, and minus the alpha between z and 1, and plus the alpha between z minus 1 and 1. And finally we can get a function like this, like here, z times mu z minus 1 times mu z minus z minus 1 times mu z minus 1 plus z minus 2 times mu z minus 2. So we can get density function of x and y in this shape. Like what we get here is like what I mean is like, because z equal to x plus 1 and the density function for x, y, and y is in this shape. So the density function of z, we can get like here. Yep, that is the density function for z we get for now. And in the second part, geometric part, it's like density function of z. We use density of z equal to probability of z smaller than 2 and equal to probability x plus y smaller than z. So it's gonna be 3 different situations. We just figure it out one by one. So in the first shape, it's gonna be z smaller and equal to 1. I just got a graph like this. This is 2 and 2. Oh, sorry. This two part is 1, and this is z and z, and this part is x plus y smaller than z. So from that, I can get the density function of y is derivative by z times z power of 2 divided by 2, and the calculated out is equal to z. And in the second situation is z bigger than 1 but smaller and equal to 2. So in the graph, the shadow part is z, this two part is 1, and from that we can get the shadow part is x plus y smaller and equal to z. So from above we can get the density function of z equal to probability of 2 smaller and equal to z is equal to like this function. Z power of 2 divided by 2 minus z minus 1 power by 3 divided by 2 plus z minus 1 power by 2 and divided by 2. And the final function is going to be like z power of 2 divided by 2 plus 2 times z and minus 1. And from that we can get the density function of z is like negative z plus 2. So in third situation, it's for z larger than 2. The density function for the z is equal to 1, like it's going to be all in the shadow part. For x plus 1 equal to z. So the density function of z is equal to derivative of z times density function of z is equal to 0. So from all above, we can get density function is of z. It's like this in a triangle shape, and by shift to 1, and it start at 1 and end at 3. Height is 1 and middle part is 2. A triangle like that. So finally we got the density function of z like here. So z minus 1 times mu z minus 1 minus 2 of z minus 2 times mu z minus 2 and plus z minus 3 and times mu z minus 3. This final answer we got. That's it, I think, for question 1. Thank you for watching.